Hey friends, in this discussion we will concentrate on 4 fundamental types of AI so that we may get holistic picture of artificial intelligence while going a little towards its core. Arendt Hinz, an assistant professor of integrative biology and computer science and engineering at Michigan State University, categorizes AI into 4 different categories, that is, number 1, reactive machines, number 2, machines with limited memory, number 3, machines following theory of mind, and number 4, machines with self-awareness. Type 1 AI, reactive machines. This is the most basic types of AI category, which is purely reactive and have the ability neither to create memories of events nor to use past experiences to infer current decisions. The perfect example of this type of machine is IBM's chess-playing supercomputer Deep Blue, which beat international grandmaster Garry Kasparov in the late 1990s. This chess-playing supercomputer, Deep Blue, can identify the pieces on a chessboard and can know how each to be moved. It can make advanced predictions about what next moves might be for it and for its opponent, along with consequences of the moves. Therefore, it can choose the most optimal moves from among the number of possible moves. But it neither have any concept of the past nor any such thing is held in the memory regarding what has happened before. Apart from a rarely used chess-specific rule against repeating the same move 3 times, supercomputer Deep Blue ignores everything before stepping into the present moment. All it does is just to look at the pieces currently on the chessboard as it stands right now and choose from possible next moves. This type of intelligence, which we have just discussed, involves the computer perceiving the world directly and acting on what it sees at the current moment. It doesn't rely on an internal concept of the world. In a seminal paper, AI researcher Rodney Brooks argued that we should only build machines like this. His main perception was that people are not very good at programming precisely and correctly to simulate worlds for computers to use, what is called an AI scholarship, a representation of the world. The current intelligent machines I surprise at either have no such concept of the world or have a very limited and specialized concept to perform for its specialized duties. The innovation in Deep Blue's design was not to broaden the range of possible moves the computer considered. Rather, the developers found a way to narrow down its view to stop pursuing some potential future moves based on how it related their outcome. Without this ability, Deep Blue would have needed to be an even more powerful computer to actually beat Kasparov. Google's artificial intelligence program AlphaGo game has beaten top human Go experts of international champion stature, but it also can't evaluate all potential future moves either. Its analysis method is more sophisticated than Deep Blue's, using a neural network to evaluate game developments. AlphaGo is the first computer program to defeat a professional human Go player, the first program to defeat a Go world champion, and arguably the strongest Go player in history. AlphaGo then went on to compete against legendary player Mr. Lee Sedol, winner of 18 world titles and widely considered to be the greatest player of the past decade. These methods do improve the ability of AI systems to play specific games better, but they can't be easily changed or applied to other situations. These computerized imaginations have no concept of the wider world, meaning they can't function beyond these specific tasks they are assigned and are easily fooled. Thus, they have a very narrow boundary within which it operates. They can't interactively participate in the world the way we imagine AI systems one day might. Instead, these machines will behave exactly the same way every time they encounter the same situation. This can be very good for ensuring an AI system is trustworthy. You want your autonomous car to be a reliable driver, but it's bad if we want machines to truly engage with and respond to the world. These simplest AI systems won't ever be bored or interested or sad. Now we talk about Type 2 AI, machines with limited memory. This type of artificial intelligence machine can even look back into the past. Self-driving cars do some of this already. For instance, they observe other vehicles' direction and speed. That can't be done in just one moment, rather, it needs reasonable time to identify specific objects and monitoring even their every minute movement over time. It therefore holds past data too in the memory. These observations are temporarily added to the self-driving car's pre-programmed representations of the world, which also include lane markings, traffic lights, and other important elements like curves in the road. They are included when the car decides when to change lanes to avoid cutting off another driver or being hit by a nearby vehicle. But these simple pieces of information about the past are only transient. They are not saved as part of the car's library of experience it can learn from, the way human drivers compile experience over years behind the wheel. So, how can we build AI systems that build full representations, remember their experiences, and learn how to handle new situations? Brooks was right in that it is very difficult to do this, but not impossible to a considerable extent. Now let us take a look at Type 3 AI, that is machines following theory of mind. We might stop here and call this point the important divide between the machines we have and the machines we will create in the future. However, it is better to be more specific to discuss the types of representations machines need to form and what they need to be about. Machines in the next, more advanced, class not only from representations about the world but also about other agents or entities in the world. In psychology, this is called theory of mind, the understanding that people, creatures, and objects in the world can have thoughts and emotions that affect their own behavior. This is crucial, of course, as to how we humans formed the societies, since we started having social interactions even without understanding each other's motives and intentions, and without taking into account what somebody else knows either about me or the environment. Working together is at best difficult, at worst impossible. If artificial intelligence systems would have ever walked among us, they would have understood that each of us has thoughts and feelings and expectations for how we should be treated, and others in the society have to adjust their behavior accordingly. Then we have Type 4 AI, that is machines with self-awareness. The final step of AI development is to build systems that can form representations about themselves, that is, about their own ambience. Eventually, the AI researchers will have to not only understand consciousness but build machines that too have it. This is, in a sense, an extension of the theory of mind possessed by Type 3 artificial intelligences. Consciousness is also called self-awareness for a reason. Conscious beings are aware of themselves, know about their internal states, and are able to predict feelings of self and others. We assume some driver beeping behind us in traffic is angry or impatient because that's how we feel when we honk at others. Without a theory of mind, we could not make those sorts of inferences. While we may be far from creating machines that are self-aware or self-conscious, we should focus toward understanding memory, learning, and the ability to base decisions on past experiences. This is an important step to understand human intelligence on its own and understand the functioning of AI too. If you are interested to further continue your reading on this topic, see the references given here. We will meet with the new AI topics in our next vlogs. Till then, keep your neurons active and keep watching. Friends, if you liked our blog and are benefited with the information given, then don't forget to subscribe it, like it, and share it. Thank you very much.